the latest adaptation of Cyrano?
What's that?
Here's Calc
Okay.
Integral.
Yeah, never mind. I'll tell you about it later. All right, so
So it's with the Rudolph,
improper integrals. This is the last section in this unit.
Yay.
So
Thank God.
this unit has gone by quickly. We will have a quiz on this next Wednesday and then a test the following Wednesday.
Why'd you say Wednesday like that? You like Wednesdays?
Wednesday.
I was just emphasizing it.
Sorry. Well, I feel bad.
I didn't say Wednesday,
That's how you're supposed to say it.
No.
supposedly, but
Like
Supposedly.
February. But then what I say
February.
February.
Yeah.
February.
All right, so improper integrals.
Oh, I thought you were being legit. I was like,
The fear that just came over my mind. Oh
no,
my
I
god.
was just like,
It's one of those times where you wish you had something that measured skin tension and be like, ah! All right, so there are actually two different kinds of improper integrals. The first type is ones that have infinite limits of integration. So our limits of integration are supposed to be finite values. So if you have an infinite limit of integration, that is called an improper integral. And in some cases, we can find the value to which it converges even though one of the limits or both are infinity. So basically what you have to do is this. Let's say that the upper limit is infinity and you have a continuous function. It's got to be continuous. If you have discontinuities, we have other problems. Then basically what we do is if we have the integral from a to infinity of f of x dx, it is equal to the limit as b goes to infinity of the integral from a to b of f of x dx. It's an extra little step that you have to write. And then you evaluate the limit. Okay, if you don't write that on a free response question, it's like, okay, sirens go off and they start going, yeah, let's crumple that up and throw it in the trash. Except you can't do that anymore because it's all going to be electronic from now on, apparently.
was it therapeutic for you?
Crumpling up a kid's paper and throwing it in the trash?
I don't know.
Absolutely. No, we don't do that.
Tear-
We can also have a lower limit of integration that's negative infinity, in which case we'll take the limit as a goes to negative infinity of the integral from a to b of f of x dx. Okay? Now, if the limit is finite, we say that the improper integral converges and the limit is the value of the integral. If the limit fails to exist for whatever reason, either it oscillates or it becomes infinitely large in some way or another, we say that the improper integral diverges. So those are your choices. Either converges and we can find that limit, or the integral diverges. If both the upper limit and the lower limit are infinite, what we'll have to do is split up the integral at some convenient point between negative infinity and infinity, frequently 0, because that's just convenient, and have two improper integrals. And in order for this to converge, both of these improper integrals have to converge. If either one of them diverges, game over, the original diverges. Okay? We'll talk a little bit more about that as we go, but I can remember that got me into trouble with one particular kind, and I'll point it out. I can't remember if we get to it today or if it's later. All right, so again, in this case, the original improper integral converges if both of the improper integrals converge. Otherwise, it diverges and has no particular value. So let's do some like these. These will not take particularly long. So for this first one, we want to evaluate the integral or state that it diverges. So you first must rewrite it as a limit. And the letter that you choose is completely unimportant, as long as you don't use x. So I'm going to do the limit as a goes to infinity of the integral from 1 to a of x to the negative 1 dx. You must keep the limit with it until you have evaluated the limit. So the limit as a goes to infinity of, well, what's the antiderivative of x to the negative 1? Natural log of the absolute value of x. We can drop the absolute value because between 1 and infinity, everything is positive. So this will be the limit as a tends to infinity of the natural log of a minus the natural log of 1. The natural log of 1, of course, is 0. There's still a little pause there, but not as bad as it was earlier in the year. And as a goes to infinity, what does this go to? What is natural log of infinity? Infinity. Remember, natural log is a very slow-growing function, but it's always growing. So this is infinite. Therefore, the integral diverges. We're going to talk a lot about things that converge or diverge. All right, page 2.
Wait, are we doing all of these today?
Indeed. That's the plan, at least. So we'll have the limit as a tends to infinity of the integral from 1 to a of x e to the negative x dx. And these are almost always evaluate without a calculator. So the question is, how do we take the antiderivative of x e to the negative x? You can't divide it when it's not added. Pardon? There is no product rule for antiderivatives. No, this doesn't bode well for the future.
Integration loss
By
by
parts.
parts. Crossing something.
Yeah, integration by parts, when you have two unrelated functions multiplied together in your integrand, you're going to do integration by parts.
Yeah.
Of course.
Okay? To save yourself from writing a whole lot of stuff, what I do at this point is I kind of branch off and do the integration by parts, and then I come back over here and put all the 1's and the a's and all that stuff in it. Okay? So if I have the integral of x e to the negative x dx, do you remember how to pick the u and the dv?
The little catchphrase. Lopus. Something. I don't know.
It's
Limit.
lipid. Thank you. So do we have any logarithms?
No.
No. What's the I?
No clue.
Inverse.
Inverse. What is P?
He said P.
Polynomial.
Polynomial. We do have a polynomial. So that'll be x, and dv will be e to the negative x dx. So du will be 1 dx. And v will be the antiderivative of negative e to the negative x, which is, or excuse me, e to the negative x, which is negative e to the negative x. So we're going to have u times v, so that's going to be negative x e to the negative x, minus the integral of v du, which is negative e to the negative x times dx. The two negatives multiply together to be a positive, and we'll take the antiderivative of e to the negative x again. That'll be negative e to the negative x plus c. So then back over here, we'll have the limit as a goes to infinity of negative x e to the negative x minus e to the negative x. We do not need to include the plus c from 1 to a. Because if we were to actually include it, you'd have a c and a negative c, and they would just add out. So this will be the limit as a goes to infinity of negative a times e to the negative a minus e to the negative a minus, substituting in 1, we've got, that'll be what, negative 1 over e minus 1 over e. All right. This last part, we do need to be concerned about it if it converges, but if it doesn't, we don't really need to. The part about convergence or divergence is right up here at the front. So it's kind of ugly. So we'll take the limit as a goes to infinity. Let's see if I can make it a little nicer. E to the negative a is 1 over e to the a, right? So let's put e to the a on bottom. And it's on the bottom for both of them, right?
Yeah.
And this would be negative a minus 1. And this will be plus 2 over e.
Yep.
And as a goes to infinity, what does that first expression do?
Go to 0. No.
Wait.
What does the numerator do?
Go to
Goes to-
negative infinity.
And the denominator?
Goes to
0.
no.
I mean,
Positive infinity.
yeah.
Yeah.
Okay, so that goes to infinity, that goes to negative infinity.
Oh, you have to go to the hospital.
Yeah, we get to use L'Hopital's
I
rule,
don't want to go.
but you're really sick.
I'd rather die.
That'll be negative 1 over e to the a plus 2 over e. As a goes to infinity,
Negative infinity.
try again.
Negative 0. Well,
0.
Yes, it is negative, but it is
2
0.
over e.
So it goes to 2 over e.
So it does converge.
Yes. So the integral converges
That was gross. I didn't like that one.
to 2 over e. For this next one, notice both the upper and lower limits of integration are infinite.
Isn't that just like... Never mind. I was just about to say something really dumb.
Okay. So I'll break this.
0.
Yeah, 0 seems like a good place.
What about 3?
Okay.
Sorry.
3 was definitely not the correct answer. Should have picked 1.
Or
0.
So I'll rewrite this as the limit as a goes to negative infinity of the integral from a to 3 of e to the x dx. And I've really kind of used a already, so I'm going to use b for this one. Yeah. The limit as b goes to infinity of the integral from 3 to b of e to the x dx. And then thinking ahead just a very little bit, if either of these diverges, the whole thing diverges.
Okay.
Which one of these is more likely to diverge? Look at it for a moment.
Facts.
It doesn't go to a number.
Second.
Yeah, the second one, because I'm going to infinity
Yeah.
with e to the x, which is getting big really fast.
Super fast.
So this will be the limit
Exponentially.
How fast?
as b goes to infinity of e to the x from 3 to b So it'll be the limit as b goes to infinity of e to the b minus e cubed which is infinity. Therefore, it doesn't matter what this one does, the integral diverges. I really like this next one.
Yeah. Actually, it's either really good news for us or really bad news for us. It's probably not news.
It's not ugly.
Okay.
Can we
It's
use zero?
it's interesting. Pardon?
If we're gonna
She was 27.
split it, we're gonna use zero.
33,
27.
40.
Let's use 0 this time.
420.
Yeah, you guys loser. Oh, Millie's a loser.
Literally go shoe shopping, man.
Sorry, bro. I'm sorry.
I thought you were shopping buddies.
No, we were until he just called me a loser. Now we're fighting.
No. You are the winner.
You're a winner also.
That was one of the things they used to do at Westfield whenever they would announce winners of something. At the end of it, they would go, and remember, you're all winners at the game of life.
No.
Wow.
They really would say that?
Some kid like has cancer.
It was hilarious.
Some kids
Or you-
actively
I
telling
know,
you
some
not
kids, like, dying.
You haven't lost yet.
Yeah.
All right, so we'll rewrite this as the limit as a goes to negative infinity of the integral from a to 0 of dx over 1 plus x squared plus the limit as b goes to infinity of the integral from 0 to b of dx over 1 plus x squared. So now we need to know the antiderivative, which of course you all know.
So, tangent cosine 1 to 4, 6, 8.
Tangent inverse.
Thank you. Tangent inverse or arctangent.
That was not your second guess.
That's what I
You
meant.
did fine
I said
guessing.
yes to me.
You never said arctangent.
Oh, I'm learning.
So the limit is b goes to infinity of the arctangent of x from 0 to b. So I'm going to have the limit as a goes to negative infinity. What's the arctangent of 0?
0.
0. Minus the arctangent at a. Plus, the limit as b goes to infinity of the arctangent of b minus the arctangent of 0, which is 0. What is the arctangent of negative infinity?
Oh.
Oh,
Where does tangent go to negative infinity is what we're asking there.
Had an asymptote.
Yeah, which one?
all of them.
Pi over 2? Negative pi over 2.
Negative pi over 2. So this is going to be minus negative pi over 2, so this is pi over 2. Plus, where does tangent go to infinity?
Pi over 2.
Pi over 2. This is pi,
Yummy.
which is not something when you originally looked at it, you would have gone, oh yeah, that's got to have something to do with pi.
Well, I did. I just did it in my head, so it didn't.
You winner.
Losing weight.
All right, so the other way that we can have improper integrals is you can have integrals of functions that become infinite at a point within the integral interval of integration. Okay, so for example, if at one of these points our integrand becomes infinite, we can rewrite the integral from a to b of f of x dx as the limit as c goes to a from the right. You're like, from the right? Yeah, because I'm going from a to b, we're going towards a from the right, even though it's the lower limit of integration. Likewise, here we can do the limit as c goes to b from the left, because we're going from a to c, so we're going from the left. And if you have one in the middle, you have to break it into two separate integrals and do both of those. Again, if either of them diverges, the entire thing diverges. So, for example, this one, where's the problem on this one?
Oh, it's doesn't got a never mind.
It doesn't exist in 2.
It doesn't exist at 2. The integrand is undefined at 2. So we'll rewrite this as the limit as a goes to 2 from the left of the integral from 1 to a of dx over x minus 2. So that's going to be the limit as a goes to 2 from the left of, what's the antiderivative of that? Of
X minus 2.
the absolute value of x minus 2 from 1 to a. So that'll be the limit as a goes to 2 from the left of the natural log of the absolute value of a minus 2 minus the natural log of the absolute value of 1 minus 2. All right, as a goes to 2 from the left, well, as I get close to 2, what does the interior of this function get close to? 0. But since it's an absolute value, it's going to be a positive number near 0. That's important because natural log isn't defined at 0 or for any negative values. But if I think about the graph of natural logarithm, as it approaches 0 from the right, what does the value of the natural logarithm approach? Negative infinity. And this is going to be the natural log of 1, which is 0. So this integral diverges.
Natural log of -1, 0.
No, this is not the natural log of -1 because I'm taking the absolute value. Yeah, natural log of -1 doesn't exist.
Yeah, I was looking at the graph.
Gotcha. All right, so for this one, where's the problem on this one?
Is that 2?
Also, yeah.
Yeah. And it doesn't really matter what the power is. That's not where the problem
It's
is.
not defined at 2.
2.
It's not defined at x equals 2. Oh, that's in the middle of this. Got to write this as two separate integrals. The integral from 0 to 2 of x minus 2 to the negative 2/3 dx. I will not. You've already interrupted me once today. You can't interrupt twice. Nope, not listening. No, 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 no. Those of you whose mommies are taking them?
Wow.
Yeah.
So anybody who's played golf in this one?
They call me Tiger Woods before I come home.
Where do you come from?
A land down under?
Australia.
Oh my goodness. How about making those announcements during the announcement time?
That would be too
What?
That's too hard.
Pull up in the Sri Lanka.
What?
I know, it's because we didn't have announcements.
Yeah, 'cause it's a Wednesday.
Wait, we don't have announcements on Wednesday?
So during second period. We
Don't
have
don't trifle me with details.
Literally, we haven't had announcements on Wednesdays for 4 years.
I thought we had them like in first period.
No.
Lily, what the
Maybe
heck?
because you're not here in first period.
I was like, how would you know?
Okay.
All right, so then this will be the limit as a goes to 2 from the left of, let's see, this is going to be 3 times x minus 2 to the 1/3 power from 0 to a, plus the limit as b goes to 2 from the right of 3 times x minus 2 to the 1/3 power from b to 3. And it's going to get a little bit worse before it gets better. The limit as a goes to 2 from the left of 3 times negative 2 to the 1/3 minus 3 times, oh, hang on a second, that's my fault. That's a minus 2 to the 1/3. My a and my 0 look a lot alike, which may be a reason why you should use b.
Or any of the letters.
Yeah. This will be 3 times negative 2 to the 1/3 plus the limit as b goes to 2 from the right of 3 times 1 to the 1/3 minus 3 times b minus 2 to the 1/3 and I still haven't written this right. That's a minus 2, right? So as a gets close to 2 from either side, a minus 2 is going to get close to 0 to the 1/3 power. 0 times 3 is still 0. So this is just going to be negative 3 times negative 2 to the 1/3 plus 3. And as b goes to 2, this is going to go to 0 as well. So it's negative 3 times the cube root of negative 2 plus 3. Woof. See if I can do the last one in 3 minutes or less. Way.
I believe so.
So again, the problem is at infinity. So I'll rewrite this as the limit as b goes to infinity of the integral from 1 to b of e to the negative x squared dx. And we have a problem. We don't know how to take the antiderivative of e to the negative x squared.
Says who?
Says me. However, this is going to be less than or equal to, at all times, the limit as b goes to infinity of the integral from 1 to b of e to the negative x dx. Now, how do I know that? Because this exponent is larger and it's negative, therefore it is smaller than this integrand. So this will be the limit as b goes to infinity. What's the antiderivative of e to the negative x? Negative e to the negative x. Ian, are you really putting everything away?
No. I just put it in my binder.
So this is going to be negative 1 over e to the b minus negative 1 over e. So what I can say on this one is that the integral converges but we don't know its value.
What good is that?
So occasionally, especially when we get into series, sometimes we're going to be interested in, does the series converge or not? And we don't really care to what it converges.
Okay,
That's a subject for
I'll take your word for it. Just
a higher level math class.
multivariable.
I did do it in 3 minutes or less.
Congratulations.
Heck, I got a minute to spare.
You did it in 2 minutes. That's actually.